All right, here is the video notes for lesson 4.2, focusing more on these trigonometric functions and the unit circle. I'm going to have us try to memorize the unit circle as much as possible, but I am also going to show you that we can use 30, 60, 90s to figure out everything around that unit circle and the trigonometric values. So again, I'm going to try to make this quick and move along so that it stays short, and that if you keep working and you go and move on to the homework, that you can try it out, see what I'm doing here, and then if you get stuck, ask me more questions along the way. So a big one here, 6 trigonometric functions. We know from geometry that we have sine, cosine, and tangent, sin, cos, tan, but we also have cosecant, secant, cotangent, and these are just the inverses of those. So the cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. And so we just call it something else, and we can now use those, and this is what they kind of represent here. So the sine of t is the kind of up and down here of the unit circle. The cosine is the left and right of the unit circle, and the tangent is kind of the rate of change here, the y over x of the unit circle. And you can see that cosecant is that flipped, secant is that cosine flipped, and cotangent is the tangent flipped. Okay. Another way to see it is that SOHCAHTOA, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Well, when you have these inverse ones, these other trig functions, they flip them. So it's hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. Here we have the 30, 60, 90 triangles. And I forgot to clear some of this beforehand, but that we'll get to these next 3 slides here. And so what we have is our 30, 60, 90 rules. Again, we did this a little bit in geometry. So the first one, if we say that this degree here is 60, this is 30, this is my 90. Across from the 60, that's a square root of 3. Across from 30, that's 1. And across from the 90 is 2. Here, if we do 45, 45, 90, across from a 45 is 1. The other one is 1. And the hypotenuse across from the 90 would be square root of 2. And we can use that to evaluate these kind of functions. So like the sine of 60. Well, we can draw that out now. And we can put it in a coordinate plane, put our triangle and say, okay, that's 60. We have the square root of 3. That means this would be 30. This is 1. And the hypotenuse would have to be 2. Well, sine tells me opposite over hypotenuse. And so the sine of 60 must have to be the opposite, which is 3, square root of 3, over the hypotenuse, which is 2. And that would be my answer. Let's see another one. So we have cosine of 3 pi over 4. You can leave it as 3 pi over 4 or rewrite it as the degree. The degree of this would be the same thing as cosine of 135. And so if we're looking at it, that is over here, 135, which is 45 degrees. 45 degrees, 90. This is a negative 1 because I'm on the left. Positive 1. Square root of 2. Cosine, I use adjacent. I use adjacent and hypotenuse. So that would be my negative 1 and my square root of 2. So I have negative 1 over the square root of 2. I need to rationalize the denominator, meaning I need to multiply top and bottom by the square root of 2, so that this becomes negative square root, the negative square root of 2 over positive 2. Or not positive 2, just not square rooted, because that's what happens when you rationalize the denominator, because technically we don't really ever want a square root in the denominator. So this is really my answer here. Okay? We'll do one more like that, the sine of 7 pi over 6. All right, well, the pi over 6 is 30, so this would be the same thing as the sine of 210. If I put that in here, 210 is right here. This line right here is 180. And so that means this is 30 degrees more than 180. So that's 60. This is, across from the 30 would be a negative 1. The hypotenuse is 2. Across from the 60 would be a negative square root of 3. That's negative 1 because we're going down here. This is negative square root of 3 because we're going to the left here. Using sine, that's opposite over the hypotenuse, and so this would be negative 1 over 2. Negative 1/2 is my answer. Okay. 6 trigonometric functions. We're just going to evaluate this for the sine of pi over 6, the cosine of pi over 6, the tangent, and then back to the cosecant of pi over 6, the secant of pi over 6, and the cotangent of pi over 6. Okay? And I'm not going to evaluate those for time reasons. Those problems can take a little bit. I do have those in my written notes, and so you can see what those look like. And if you want to see it evaluated further, or you get stuck on the homework problem, let me know, and I'm happy to show you that. So we have a couple of those where you're evaluating all 6, and that's a lot of what we had there. Domain and range of cosine and sine functions. These functions are really waves, and we'll get into that later on. And so these wave functions, they have a maximum and minimum point, our range. So they'll go up to 1, and then they'll dip down to 1, and they'll repeat this wave function. And the domain, because they're just going to wave from left to right, it's all real. Every function here has a period of 2 pi, meaning that after, it is like a wave function, like I said, and after 2 pi, after 360 degrees, it just restarts. And so that's the same thing as we were talking about in the first lesson, saying that, okay, every 360 degrees, we have the same coterminal. Well, that's the same kind of thing with this period, is that we get to say the same, like the sine of pi over 6 is the same thing as the sine of pi over 6 plus 2 pi, or the sine of pi over 6 plus 4 pi, because we have that repeating after every 2 pi, okay? And so here we can use that to help us solve functions, because the sine of 13 pi over 6 could be a little bit more difficult, but what if we hop back a period and see what it is? And so what I'm going to do here is I'm going to take 13 pi over 6, I'm going to subtract 2 pi to make it more manageable. And so this becomes 13 pi over 6 minus 12 pi over 6 pi, multiplying here to get a common denominator, and this becomes pi over 6. So I can, instead of taking the sine of 13 pi over 6, I can do the sine of pi over 6, which I know is the same thing as the sine of 30 degrees, which, if I drew it out, that's 30, 1, 2, it's 1/2. Okay? Now, a little bit about even and odd functions. Pretty much what happens here is if you plug in for cosine, if you did the, because cosine and secant are even functions, sine, tangent, cosecant, and cotangent are odd. If you did the cosine of, let's put it on the board, sorry. If I do the cosine of, if I do cos of pi over 2, that gives me 0. And the cosine of negative, let's do pi instead. The cosine of pi would give me -1. The cosine of negative pi would also give me -1. So the answer doesn't change whether you plug in a positive or a negative, and that's how we know it's an even function, based on, like they're saying here, the output is not going to change due to if you're plugging in a positive or negative. Now, for something like the sine function, if you did sine of pi over 2, you end up getting a +1. If you do sine of negative pi over 2, you end up getting a -1. Okay? We'll work with more with that in homework problems. And again, if you want more clarification of how that works, you can kind of play around with that idea too, plugging in positives and negatives even into your calculator if you wanted to see, okay, if you plug in a positive, you're going to get a different answer than you plug in a negative with sine, whereas cosine, you'll get the same answer. And that goes to cosine, secant, and then odd, sine, tangent, cosecant, cotangent. All right, so then we have here just evaluating this, and so this is the cotangent of -t. Because cosine is an even function, the cosine of -t is the same thing as the cosine of +t, and we know that the cosine of +t is -3/4. Same thing with secant. Secant's an even function, so this is the same thing as secant of +t. And so then this would become 1 over the cosine of positive t, which is 1 over negative 3/4, which becomes negative 4 over 3. Okay, the sine of t, or the sine of negative t, equals 3/8. Okay, well, the sine of negative t is the same thing as the negative sine of positive t, and so this would become negative 3 over 8. And my cosecant here, that's like the same thing as the 1 over the sine of t. We know the sine of t to be negative 3/8, so that's 1 over negative 3 over 8, which changes to negative 8 over 3 as your answer. Okay. Last thing is just being able to do this in our calculator. And if we want, our calculator doesn't generally have, unless you have a scientific calculator, which many of us don't, we can always just do 1 divided by the sine, 1 divided by cosine, 1 divided by tangent to find cosecant, secant, and cotangent. Okay? And so here, like sine of this, we can plug in. And if we don't have radians on our calculator, we can always change it to degrees. Here we can plug in, like this would be 1 over the tangent, so 1 divided by the tangent of 1.5. And like cosecant here, that would be like 1 over the sine of 3 pi over 4. Okay, and we can plug those values into our calculator and solve. Again, I'm going quickly, I know, but I want to keep these videos short. I want to just give you the information that you need, and then you can ask questions when you start working on homework, because homework is going to address all of these questions even further. And that's what I would like us to do is, again, focus on the homework, focus on practicing, and then asking questions where we get stuck. Also joining us for tomorrow's lesson, if possible. And if you were able to, then hopefully we don't need these help videos as much.